Hello Math 10. We are going to be looking at function notation. This is section 5.5 in the workbook. Looks like it starts on page 218. So we're just going to go over sort of what this is all about. It's called function notation because it's all about functions. We talked about exactly what a function is. It's a relation, or you could think of it as, I guess, an equation. Two numbers are related, and for every x point, there's only exactly one other value of y. So that is our definition of a function. We see the vertical line test we see on graphs and such kind of demonstrate that. So we're working with lots of functions. All these linear equations are functions. They're one-to-one functions in particular. We found out about that meaning. But more importantly, there's a way of writing these that has become very popular in mathematics. It sort of makes wording these questions a little more concise and actually can be used for some pretty cool things that we won't really see today too much, but will be, I think, we're kind of opening that door to peek inside to see those things today. We're just going to learn the nuts and bolts of this notation that people use for writing functions. And basically, we're going to do away with the letter y. Not going to see y anymore. Y is still a thing, and the new notation will still imply the y-axis when we're graphing things, but it's just going to look a little different, and that's all. And you don't have to treat it as anything more fancy than that. That's just what's happening. That's just the new style of writing these equations. So here it is. This is it. This f of x. It doesn't have to be f, by the way. It could be g or h of x. But it's sort of implying that f is a function and it depends on x. And this is just how we're going to write y from now. We're going to say f, 2 parentheses, and an x. That's just our new style of writing a y. So for example, here, this was your equation here, y equals 2x minus 4. You could rewrite it as this thing here. F of x is how you pronounce that. F of x equals 2x minus 4. So we're saying that this sort of the y is a function of x. Here's the equation, and you can go from there. And that's a way to translate into this new function notation. So, okay, that's great. Let's take a look and see what we can do with this. So, for example, here's a classic type of question. In the old way, we would have written it like this. Given y equals 2x minus 4, find y when x equals 5. So that's fine. That's a nice question. But we have a new way of saying that, and that is f of 5. We can give the function f of x equals 2x minus 4, and then we can say f of 5. That's saying, if we're saying find f of 5, we're saying find the y value when x is 5. That's just what that means now. It's just like a faster way of writing that. So f of 5 here, like in this bold notation, I think this is very important to see the bold. It says the notation f of 5 implies the value of y when x is 5. So you're basically going to, whoa, my mouse went crazy. You're basically solving this equation for when x is 5. That's the story, mostly. There's more to it than that, but we'll go forward and see how this works. Here's a great example. F of x equals 3x plus 5. If that is our function, then we're supposed to find 1 point on the line for f of 2. So in other words, f of 2, we're saying the x coordinate is 2. What is the y coordinate? Well, I just plug 2 in here, and we'll find the corresponding y value. And that's what the person did here. If x is 2, they plug in 2 for the equation, and they get 11. So there's our point. We'll see that there is also, if we could say f of x equals negative 7. What we're saying there is y is negative 7. What's x? Find x. So then in our equation, which was given to us, same equation as example 1, we can substitute f of x with negative 7 and then use algebra to solve for x. So f of x often just means y. That's a big takeaway. It just means y. However, it's got this sort of new notation that gives you the value of x built into it. It both means y and shows you what x is. And it implies that connection between the two a little more seriously than just the variables y and x. So let's move on. Let's go straight to the questions in the homework. Here's question 1. Here's a big old table of stuff you're supposed to fill out. The idea here is, here's x. What is, and here's the function. They're using g here. Don't let that fool you. No big deal. G of x equals minus 2x plus 3. So they're saying x is 2. So then you have to rewrite all of these things. And I'm going to try and do some of this. So if x is 2, we know x is 2. Then minus 2x plus 3, if this is our table, minus 2x plus 3. We're just going to substitute 2 into this equation. So we get minus 2 times 2 plus 3, which is going to be minus 1. It's just going to work out to that. I guess maybe I could show you that in 2 steps since we have the room. I know x is 2, so I just plug in x as 2 for this equation or this function, and then I just multiply it out, and that's why I get negative 1. Okay, so that equals negative 1. How about the next one? G of x. What is g of x? If x equals 3, it almost seems like a trick question, but that's all they're talking about is g of 2. That's what that means. And the last one is the xy point. What is the xy point? Well, we know this evaluates to negative 1 when x is 2. So our xy coordinate is x is 2, y is negative 1. That's our xy. That's a terrible x. I'm trying. I'm using my finger here. It's the best I got. See how you fill that out? That's basically the story of how you fill this out. My chart is horrendous. I'm just going to do a quick reset of this chart here, and we'll try another couple of them on question 1. Okay, so we have x. Oh, that's supposed to be an x. Oh, man. I want my pen back so bad. Anybody got a spare Dell Active pen they could lend me? So that's x. We have, is it minus 2x plus 3? We have g of x, and we have xy. Okay, so I think a lot of these will be pretty straightforward, at least this one. What about 2c? What's 2c? Well, you can plug a 2c in for x. I mean, it's not super pretty, but if x is 2c, then this becomes negative 2 times 2c plus 3. Okay, great. Try to simplify it as much as you can. So do any multiplication. So I can get minus 4c plus 3, for example. Simplify it as much as you can. How would you write g of x? If x is 2c, it would be g of 2c. And our coordinate would be x is 2c, and y is negative 4c plus 3. That's pretty wild. So if that was our point at x, and we have already gotten that y. It's getting a little bit crazy, isn't it? But that's the idea. That's what's going on. There's one more here, and that is c minus 2. So, I mean, there's actually a couple of them. So if it's c minus 2, then if we plug that into our equation, we get minus 2 c minus 2 plus 3. And we can just multiply that through and see what we get. We should get, we'll multiply it into the parentheses. We get minus 2c plus 4 plus 3. I'll have to scroll down a bit. Whoa, that's not a bit. So plus 4 plus 3 is plus 7. And g of x is just g of c minus 2. And xy, well, there's just what's x. X is c minus 2. Y is that big thing, minus 2c plus 7. That's all we're doing. We're just plugging in numbers, really. That's the main thing. For g of x equals c minus 1, we're going to have to solve our equation for x. So g of x becomes minus c plus 1. and we'll have to solve for x. So you'll have to do some algebra to find this one. So that's basically what's going on for question 1. For question 2, it's a little bit easier. We just have to find f of x given these various values. So we'll just do ACE. For question 2, I'll scroll down, I guess, I don't know, or just erase this crazy mess. I can't erase. Come on, I see the eraser selected. Yeah, I don't know. I mean, you can see it too. It's selected. Why? I don't know what to say. Oh, my mouse works apparently. Oh, there it goes. I don't know. Whatever. I'll just erase some of the stuff. So for question 2, yeah, f of x is 3x minus 2. So this is number 2. Oh my gosh, f of x equals 3x minus 2. So then they're asking, hey, what's f of 3? So f of 3 is just going to be 3 times 3 minus 2, which is going to be 9 minus 2, which is going to be 7. So that's what f of 3 is. Some of them get a little trickier, though, like what about f of x plus h? Oh my gosh. That's okay. No big deal. F of x plus h, we're just saying x is now x is just x plus h. So we just plug in x plus h where x was. So we'd get 3x plus h minus 2. We're going to have to multiply that into the parentheses like this. So we get 3x plus 3h minus 2. Can't really simplify it any further. That's what it is. So do you see how this thing inside the parentheses is plugged in? That's the story. That's what's going on here. And that's why that's the answer. Similar question to number 3. We have f of x equals 4x plus 5. Same values, but different function. Question 4, similar kind of thing. New function and new values. So you can, at this time, we're going to be setting f of x to a number, so we'll be solving for x. We need to find what x is when f of x equals negative 3. So let's do number 4. We'll do a couple of those together. Again, I'll try to erase. Can I erase? Oh yeah, it's erasing this time. Wow. So good. Kind of. Hello? Oh, yeah, we'll erase these ones. So question number 4. This time we know f of x is minus 5x plus 2. So if we know that, say for example, if we did C, f of x equals negative 12, then we just put in negative 12 for f of x, and we solve for x. So in order to solve for x, I need to get x all by itself. So maybe I'll subtract 2 from both sides to get rid of this 2. So minus 2 gives me minus 14 equals negative 5x. And then I divide both sides by negative 5, divide by negative 5, divide by negative 5. Can't really divide 14 by 5 very nicely, so we'll just end up getting that as a fraction. So the negatives can cancel out, but x is going to equal 14 over 5. And that's a totally fine answer for us. So there we go. That's what we do. So this time, this becomes, we're saying the y is this net value, find x. That's what that implies. So we're doing pretty good. Ooh, look at this, some graphing. Yes. So happy to be away a little bit from our algebra. So this is going to be no different than any kind of graphing we've done before. F of x equals 2x plus 1. This is the same thing as y equals 2x plus 1. So we can use slope-intercept formula. I don't think I can draw on this, but basically I'll see this as my intercept. That is my slope. So I'll just draw a point at my intercept and then use the slope to rise and run. So it's really the same as everything we've done. So these questions actually will be pretty nice. They're all in y-intercept. Oh, f of x equals 3? Ooh, what's that? That means y equals 3. Is that a horizontal or a vertical line? Stumper. So you guys think about that. When y equals 3, is that a horizontal or vertical line? And then draw it accordingly. Remember, in all these graphs, just think of f of x as y. And then you can graph this. You even notice that this axis is now called f of x. That's cool. That's fine. We can call it that. It just means y, really. It's a different way of writing it. Yeah. Let's see. Question 6. It says graph each function if the domain is -3, -2, blah, 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 blah. So basically, they want you to plug in these values for x and find the points for y. So, or for f of x, I guess I should say. So these are our x values. Plug that in and then plot it on the graph. So you're not going to draw a line here. You're just going to draw all the points when x is -3. You're going to find out what y is, what f of x is, and then plot the point and so on. And just do it for all these different values. So that will be, we'll just do ACE for that one. And there we go. Woof, getting some spicy stuff in here. Look at this question 7. We got pi inside of it, so that's always kind of weird. But that's okay. Pi is just, I think we can approximate it. I'm not actually sure what the answer key says. If the answer key doesn't have, if it has pi in the answer, then that's fine. We can leave pi in the answer if it's looking for an exact answer. If it evaluated or estimated pi as some number, then it'll be a decimal number, and we can just see what they chose. But I think I'll leave my answer as pi. So let me go over to my terrible workbook here. Let's see, can I go down? I'll just erase, I guess. Let's solve question 7 together. Using my finger like an eraser, we can do this. Yeah. Ho, ho, ho. This is so bad. I wish I had a whiteboard. So this is, again, question 7. It says g of r equals, that's an r, 2 pi r. 2 pi r. That sounds like a circumference or something. So then what is g of 0.5? So g of 0.5 is basically going to substitute r with 0.5. So it equals 2 times pi times 0.5. So then I would just multiply 2 and 0.5 together. I can't really multiply pi with anything, but 2 times 0.5, I'll just rearrange the multiplication. You can do multiplication in any order. That ends up being 1 pi, or just good old pi. We can just say pi. So that's the answer. So we're just substituting it in. You can plug in all sorts of things in here, can't you? Here's another one, for example. We can plug in 0.5 or h and see what we get for our function. So these are just showing us what are the values of x, or r, I guess, when we plug this in. And just some more examples of this. Question 9, same kind of idea. We're just plugging in a value for r, and we're finding out what the resulting thing is. So that's all it is, just plugging in numbers. So for question 10, same thing. Let me know if you're having trouble with any of these. I'd be happy to help out. I'm going to kind of leave you to think about them and see what you can do about those questions. Hopefully it'll go well, and if not, then send me a question on Teams and I can make some more videos about this. It might surprise you that it's simpler than you think it is. Some of these questions actually are, once you know how, you'll be like, oh, is that all that was? Cool, I can do that. But sometimes, if you aren't there yet, this can seem very confusing and difficult. So again, the solution is just ask more questions. And I look forward to seeing your questions out there on Teams, or maybe if you come in on a flex time. Okay, thanks for putting up with my terrible pen. It's just, this is not a pen. I don't know. I feel terrible about the quality of the writing, but I feel awesome about you and your questions, and I look forward to seeing you or hearing from you on Teams. Okay, thanks everybody. Bye-bye.